Alright guys, this is 5.4. Today we're going to be talking about the quadratic formula again, but our answers here aren't going to be rational. So like all of our examples here that we had last time, we ended up having like integers, whole numbers, fractions, okay? Today you're going to be running into things that you might have irrational answers, like the square root of 2, or you could have imaginary answers, like 2i, okay? So I will get into those. I think we'd like to go over these 6 problems. Feel free to pause. You should be able to get pretty far on what we did last time. It's just when we get to the simplifying part. So everything else is the same. We're going to make sure it's in standard form. Everything's on one side, equal to 0 on the other. Identify A, B, and C, and plug it into the quadratic formula, and then we just need to talk about simplifying, okay? And that will be a little different. So first off, this is in standard form. Check. Perfect. Let's identify A, B, and C. So here A is 1, B is -9, and C is 15. Okay, so we'll plug that into the quadratic formula. So we'll have x equals -b, so -9 plus or minus the square root of 9 squared, so -9 squared, so b squared, minus 4 times a times c, all over 2 times a, which is 1. Okay, so that shouldn't be like a surprise. We did all of this last time. Our next step will be the same as well. We're going to simplify what's inside. Okay, so simplify what's inside the root. Okay, so for this one, it's -9 squared minus 4 times 1 times 15. Okay, so we'll put that into our calculator and we'll see what we get. Okay, so I've already done mine. I've typed that in already, and I end up getting, sorry, I'm at the wrong spot. I end up getting 21. Okay, so x equals 9. So again, we had this double negative here. So it'll be +9 plus or minus the square root of 21 over 2. All right, so the next 2 steps were to simplify the root. So today, again, sometimes we'll be able to get a nice square root, sometimes not. This is not a nice square root. Square root of 21 isn't an integer. Kind of like when we did the square root of 9, that's just 3. Okay, that doesn't work out today. So the square root of 21, we would maybe try and do like a factor tree, but there's nothing that we could even do. 21 is prime, so there's no groups. We can't take anything out in front. And because of that, we can't simplify the fraction. So this is actually our final answer. In some ways, ugly numbers makes it easier for you. Okay, so this is our answer. I'll give you an example next where we'll be able to go a little further in example B. All right, so same sort of thing. Check and see if it's in standard form. Yep, it is. Next, identify A, B, and C. So we've got A is 2, B is 8, and C is -1. Plug it in. So x equals -8 plus or minus the square root of b squared, so 8 squared, minus 4 times a times c, all over 2a. Okay, so again, first simplifying step is to simplify what's inside the root. So again, use your calculator, type 8 squared minus 4 times 2, sorry, that looks like a 9. 4 times 2 times -1, and we should end up getting 72. So x equals -8 plus or minus the square root of 72 over 4. Okay, so this time we actually can simplify our root. It's not a nice square root, but we can do a factor tree. So again, start with 2's until you can't do 2's anymore. So we could do 2, 2 and 36. We could divide 36 by 2 again and we'd get 18. Divide it by 2 again and we'd get 9. And then you can't divide 9 by 2, so next would go and try 3. And 3 works, it would give us 3. So again, we circle groups or pairs. So there's a pair, and 2 over here isn't in a pair. Okay, so if you remember when we do this, well, let's write this part out. So circled or paired numbers can go out into the front. So that would be, I'm just going to write that over here. So we'd have 2 times 3 square root of what's not in a group, which is a 2. So we'd end up getting 6 square roots of 2. Okay, so that went back to our first lesson. If that doesn't look familiar, please go back to our first lesson this unit and watch that video again. Okay, and then our last thing is to try and simplify our fraction. So last time we could just add all of these types of numbers and it was great. These are not all the same type of numbers. We have rational and we have irrational numbers, and we don't want to add an irrational number to a rational number because it will give us a decimal that never ends and has no pattern, and we would have to round and it wouldn't be exact. So we want exact answers. But one thing that we can do, and please remember this is always the very last step, is to simplify the fraction. We look at the 3 numbers and we'd say, oh, I guess I don't need to write oh. We can divide 8, 6, and 4 by 2. So look at these 3 numbers. Again, these are the numbers that are not in a root. We want to compare those and say, well, what could we divide all 3 of those by? And we can divide them all by 2. Okay, and that is like when we simplify a fraction, right? If we have negative 8 over 4, oh yeah, that can simplify to like 2, right? Maybe that wasn't a great example. Okay, but the thing here is we want to do all 3 of those numbers together. So we could divide all 3 of those. Maybe I'll just put, we're dividing it by 2, dividing it by 2, and dividing it by 2. So we would end up getting our final answer. This is the very last step. We'd get negative 4 plus or minus 3 square roots of 2 over 2. Now it's kind of hairy, but this is what we end up getting. Okay, and you might say, well, Mr. Warner, I can divide 4 by 2 again. Like I could divide these 2 again by 2, but we want to do them all together. Okay, we want to keep this as one fraction. All right, so let's try a couple more. Again, first thing is make sure it's in standard form. That's not in standard form. So we'd want to add 2 to like terms. So we'd end up getting 3x squared and then minus 10. Okay, identify A, B, and C. Ooh, this looks a little different because we only have 2 terms. So we have to remember if a term is missing, what term is, if a term's missing, which one is it? So this would be like 3x squared plus 0x minus 10. So if it's helpful, add the 0. Okay? So A is 3, B is 0, and C is negative 10. So we'll plug it all into the quadratic formula. Sorry, that is a 3. So x equals negative b, which is 0, plus or minus the square root of 0 squared minus 4ac, so that's 3 and negative 10. But you never knew that in math that you'd be a singer. Okay, all over 2a, that was bad. All over 2a, that's better. Okay? So again, we're going to do the same steps. We're going to simplify, simplify, simplify. So first thing, we're going to plug in all of this into your calculator. 0 squared minus 4 times 3 times negative 10. And we're going to end up getting 96. So we'll have x equals negative 0. Well, what is negative 0? Do we have to keep it? We don't. So we're just going to have plus or minus, sorry, the square root of 96 all over 6. Okay, so next we wanted to see if we could simplify the root. So we could do 2. We could try 2 and 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3. Circle groups. So we have a 3 that we know is all by itself. We don't have any other 3s. There's a group. There's a group. And we have another 2 that's by itself. Again, we don't use, we only use the prime numbers. So we'll end up having x equals plus or minus our groups that are circled. That's 2 and 2, so that's 4. Square roots of what's not in a group, so that's 2 times 3, which is 6, all over 6. Okay, so here is a good question before we simplify any further. What is the square root of 6 over 2? And what people do is they say, oh, well, 2 goes into 6, but the thing is that this is not 6. This is the square root of 6. This is some crazy decimal that has no pattern, and you can't divide it by a nice number, okay? So we can only simplify things if they are outside of the root, or I mean the fraction. We can't simplify the fraction. So here, I know last time we compared 3 numbers, but that third thing is missing. It's gone, right? The 0. It's not going to help or simplify. Okay, so we're just going to look at those 2 numbers, and we would say, oh, well, we can divide 4 and 6 by 2, so we'd get 2 square roots of 6 over 3. And that would be our final answer. Okay, so don't ever try and divide something in a root by something that's outside of a root. Okay, all right, we're getting through, halfway through. Okay, all right, so again, this is not in standard form, so we would subtract 5. Okay, and I tried to make these these problems be what we actually need. So there's not any that are a little different. I mean, the same, I should say, sorry. So I'd encourage you to make sure that you understand all of these before you stop watching, okay? So here, A is 1, B is negative 4, and C is negative 2. And we'll plug it into the quadratic formula. X equals negative B, so negative 4 plus or minus the square root of negative 4 squared minus 4 AC, so 1 and negative 2, all over 2A, which is 1. That's another reason why I like people to write this out, because it's easier to just plug it in when you already have it identified, especially if there's like a term missing. Okay? Simplify what's inside the root. So here, again, we just use our calculator. Negative 4 squared minus 4 times 1 times negative 2. Okay? So we'll end up getting 4 plus or minus the square root of 24. Sorry, my 4s do not look like 4s. And sometimes my 2s look like Z's. All right, okay, so we simplified what's in the root. Now we'll simplify the root. So again, maybe start with 2, would get 12, 2 and 6, 2, and 3. Circle groups, non-groups stay inside. So here we'll end up getting x equals 4 plus or minus 2 square roots of 6. So again, this will give us our 6 when we multiply those. And again, we're only taking out 1, 2 because we're doing the square root of 4. And the square root of 4 is just 2. All right, all over 2. Okay, so here's another example where we have 3 numbers that are out of a square root. We want to see what can we divide all 3 of those by. We can divide them all by 2. So here we'll end up getting x equals 2 plus or minus 1. Again, we don't need to have the 1. Square roots of 6. Okay, so you could have it there or not. And then it's all over 1. Again, we don't need to have that either. Dividing something by 1 doesn't change it. Okay, so this would be our final answer. All right, we have 2 left. Again, I'd encourage you, if you would please, to pause and see how far you can get without getting any help. Okay, so this is in standard form. A is 7, B is -10, C is 5. Plug it in. Again, here we have a double negative. Okay, this will happen, so watch out. Please make sure you take care of that. Make sure you use parentheses when you plug in. So minus 4a c all over 2a. Okay? Same first steps. Again, there's nothing different here from last time. We'll want to evaluate the inside part. So plug -10 squared minus 4 times 7 times 5, this whole thing, into your calculator. Okay? So we're going to calculate that. -10 squared minus 4 times 7 times 5. And we end up getting, you should get -40. Oops, messed that up. Okay, so what do you notice that's different this time? So we end up getting a negative inside of our square root. So remember what that means? It means we're going to have an imaginary. Okay, so right away, if you wanted to, we could make this be positive and put an I out in the front. And then we're back to where we were before. We'd want to simplify the square root of 40. So we could do 2 and 20, 2 and 10, 2 and 5. So we've got a pair of 2's, and this 2 and 5 have to stay inside. So we'll end up getting x equals 10 plus or minus 2i. So the 2 again comes from here. The I comes from that -1 that we took care of. And then the square root of 10, again, that comes from the 2 and 5. That's not in a group. All over 14. Sorry. Okay, so we simplified the root. The last thing is to check the fraction, see if we can simplify it. What could we divide 10, 2, and 14 by? Again, it doesn't matter if it's imaginary. You can still do half of an imaginary number or a third of an imaginary number. You can divide numbers. You can multiply numbers. You just can't add or subtract imaginary and an real. Okay? So here it looks like we could divide everything by 2. So then our final answer is 5 plus or minus 1i, or you could just do I, square roots of 10 over 7. All right, last example. Again, I have these other 2. I have those filled in on the notes. If you want to give those a try, that might be helpful. Okay, this last one is a nice one. I really like this one. So let's make sure we get this one done. So we'll add 12. So standard form, everything on one side. So 5x squared plus 4x plus 4 equals 0. Identify A is 5, B is 4, and C is 4. Plug it into the quadratic formula. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Okay, so we plugged it all in. Simplify the discriminant, what's inside. So plug this in your calculator. And you'll end up getting negative 64. So we'll plug that in, or write down our new simplified problem. Okay, so again, this is why I encouraged you last time to don't skip steps. So if you just tried to type in the square root of that number, your calculator will give you an error because of that negative. So we have to kind of do this step by step. These are the types of problems you're going to run into on the test. You probably won't run into any like last time where our answers were really nice. Okay, so again, we have a negative inside, gives us an I. And then the nice thing here is the square root of 64 is a nice number to square. You could just use your calculator and you would get 8. But if not, you could do the factor tree. It will still work. Okay, so we'll end up just getting x equals negative 4 plus or minus 8I over 10. And then we'll do those, check those three things. What can we divide 4, 8, and 10 by? Okay, we don't really care about the sign because we'll still be able to divide it. So what can we divide them all by here is 2. Looks like most of the time it's a 2, but it could be something else. Okay, so our final answer would be x equals negative 2 plus or minus 4I over 5. Okay, all right, well, if you have any questions, please let me know. This worked out for you. We'll see you